that might be going wrong, whether I've got a blown component or something, or anyway. But it's all there. All the bits are there. All the pots are there, and yeah. So I have been doing work, but I haven't actually got to the point of on the 30-volt side to make it operational. But I keep being thwarted. I think I'm almost there. I've got an hour. I can do this. And then something else happens. When you think you've got a minute, you haven't. Somebody else needs help and goes wrong, or anyway, never mind. I will get there. Oh yes, that's the circuit, Chris. I can see that now. That's 32QX, isn't it? Yes.
Yeah.
Right. And the sequence for that, you're right, was that you're going to go for B plus on the upper plate while the lower plate is off, and then you're going to switch round and put B plus on the lower plate while the upper plate is off. Yeah.
To reduce that to the most simplistic form.
Are you having any gap between when instantaneous switch over, is it? Are you having any gap at all?
No.
Between? No, right. Okay.
There is no T3 A and B in this circuit.
Indeed. Okay. You're right, there isn't. Yeah.
Because the 9XC gate card controls the flip-flop of the two, there's virtually no off. It's
Right.
always 180 degrees out of phase.
Yeah. Okay. Right. Okay. So that you reckon you've done that with your coding then, have you now?
No. I did this with an old-fashioned, keep it simple, stupid, crude method because I wanted to eliminate all the possibilities. Okay, so
Yeah.
reading through the literature, Stan points out that we need to have attenuated voltage. So this is one piece of this that may still be a factor. But he used a transformer to get higher volts, whatever, and the chokes and so on. No indication of resonant action or of electrical resonance that is mentioned at all throughout the circuitry related to the steam resonator, right? So anyway, I tried to think, how could I make this as simple as possible? Well, what I ended up doing was taking just a single pole double throw relay, just one side of, like, just pretend it's a double throw, double pull, double throw, with the two poles go back and forth. I'm just using one side of it per se. So I've got the positive on the pole, the B plus going right to the pole, and then the relay flips back and forth at the flip-flop frequency, and it basically transfers the B plus reference from one electrode to the other without having a negative connection. The biggest challenge to this whole process is to make a positive reference on one electrode. You have to have a negative electrode reference somewhere. You have to be able to conduct current. In the case of a transistor, you have to conduct current if you want to put positive volts on the other side of that transistor.
Yeah.
Stan figured out that you can use a transformer and do it without a return path to ground. And that's what we see with 32QX.
Yeah.
Whether it's fly forward or flyback mode, I guess it doesn't matter in a sense, the operation, because positive is just going to go one direction, but the opposing blocking diode literally prevents current from flowing. So while the voltage is made available from the magnetic field and the polarity of the coil, and it's a reference even without current flowing. So
That's always puzzled me when I've looked at these circuits, but now you've explained it, I can see what he was possibly trying to do then. Okay, right.
Yeah, so you don't have to know about how the inductor works at all. I mean, to understand it, it's just the inductor will, like a transformer, if you hook AC up to one side, the other side's going to respond, and you're always going to have a potential there, even without a path to ground. But a transistor, on the other hand, cannot do that. So if you come emitter out of an NPN or a PNP, whatever, it's not going to turn on. It's not going to conduct unless there's path to ground.
Yeah. Quite right.
Chris,
Positive.
what I'm seeing in this drawing is not, it's the similar thing what I have as a center taped transformer. Only he made also not just the primary side, but also the secondary side center taped. Actually,
Yeah, and I think they're bipolar. Or no, they're not. Sorry.
No. This is center taped. Actually, this is what I have mentioned last time when I which was presented in the meeting.
Yeah, getting that center tap on the secondary side is something like that just doesn't exist. You can't buy a transformer like that. A step-up configuration, I mean, with a center tap. Well, you can, but not in, what we're looking for.
And he used also in the primary side the center tipped version in order to not saturate the transformer. This is what I have mentioned last time, that it's very important, and I start to investigate that.
Yeah.
It's enough just to have the secondary. So it was clear for me that the secondary side must be a center tip, because otherwise you don't have the possibility to doubling the frequency in the secondary side.
Wait. Say it again. The last part.
Yeah. So if the transformer are not taped, especially in the secondary side, you will not obtain the frequency doubling. So let's say that you are working with 1% in the primary side, and to obtain the double frequency in the secondary side, you can obtain only if you have a center tape, because the negative side, so actually you will not have only slope between the positive side and to the ground, but you will have also in the meantime one slope to the positive side, and the second slope you will get in the negative side. And due to these two, what you actually are the get frequency doubling.
Or just, I guess you're playing circuit interaction.
That makes sense. In this arrangement with 32
I don't know, I can not explain why, but I know that this is how it's working, the center tip transformer.
Yeah. Well, I mean, so it makes sense. In this arrangement with 32QX, the off cycle is gonna fire the opposite side, but it's just a mirror, so it doesn't operate out of phase out of polarity. It's not a negative voltage on the other side. It's literally just drawn that way to make it to be bipolar, but it's really not.
That
32QX.
diagram, that 32QX diagram is showing a center tap on the primary and the secondary that are linked, and all of it goes to ground right through the middle of everything, doesn't it?
Mm-hmm. This is a tactic to force unipolar operation.
Right.
Always bias it forward.
So we.
Okay. Well, let me get to the main event here. Just show you this. All right. So I forgot.
Only what I have done last time that I changed it with the drawing. So the negative side of the secondary the diode, it didn't go directly to the VC2, but also it was connected to the end of the cathode side from the positive side of the transformer to the VC1, or the VC1 is starting.
Okay.
And of course the VC2 was connected directly to the ground. Because my theory is that we have actually a buck converter.
I'll get somebody here to argue with you about that.
I mean, all the cities has a buck converter.
Speak of the devil. I'll
Why?
get somebody here to argue with you about that.
Yeah, Tony?
No. Let's see if he comes on.
But who?
Davey.
Ethan?
I think. Oh, Ethan is here. I didn't even see him. Oh, hey, man.
Yeah.
Davy's here also. I invited him to speak. All right, so before we go down that road, let me show you this real quick. All right, so here's what we're doing. So remember 32QX. Now, there's two probes here. You can see on the tape. And that is the tooth. You can't see my camera again?
No, we've still got
Oh my God.
still the diagram.
There are two squares that are rotating and nothing else.
Wait a minute.